The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Today we're getting back to the super glue gun build.
That's correct. In previous episodes, we worked on the extruder, the hot end, triac control, and we picked a microcontroller.
So where are we starting today?
What we're gonna do today is we're gonna take that foam mock-up that we did of the gun and design a PCB that will fit inside of the handle. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
So this is our H-bridge, and what our H-bridge does is it controls our motor. We have our input here, which is going to be like our 12 volts coming in to drive the motor. And then we have all these control pins, which are going to make this circuit switch the terminals that are connected to the motor. So when it's going forward, say this might be positive and this will be ground. And when the microcontroller switches these pins to adjust the input, this would be positive and this would be ground, thusly reversing the direction of the motor. So I've connected the terminals of this motor driver to the motor. I'll plug it in, give it some power, flip the switch to turn it on. All right, so I'm doing this just as one final test to make sure that this circuit does work, because we did this a while ago before we start hacking up and reducing components. Okay, so there's a motor turning one direction, there's a motor turning the other direction.
All right, I've cut two of these PCBs in the shape of a gun handle. I need to take into account the trigger though, because it's going to be moving. So we might actually have to cut a space out for the trigger motion, like right there, if it rotates on a pivot point there. And if there's a magnet in the trigger, then we'll probably put the Hall effect sensor somewhere along this arc. Of course, that eats up even more of our space because we need, power supply on the bottom, microcontroller, op amp, triac, the H-bridge. We've got to make it all fit and then have a plug at the bottom for AC power. We could probably just steal one of those off one of the existing glue guns. Unless the trigger was hollow, like if the circuit board is in the center, well, the thing is the circuit board won't be in the center. It'll probably be off center because you're gonna have the through-hole components on one side, which are pretty much unavoidable with a power supply. So maybe we don't have to cut apart the circuit board. Maybe the trigger could just pass over it. And we did make the circuit board smaller. See how it doesn't come anywhere near the outer shape of the gun, which means it could be off to one side like that. Yeah, I think I'll do that. Felix got these little regulator packages. I'm going to take them apart piece by piece and see what's on them. So it looks like the first thing coming from the live and neutral, which is AC. First thing hooked up to those lines is a little surface mount chip. I looked it up online and it is a bridge rectifier. Bridge rectifier is where you take 4 diodes and you use that to convert an AC voltage to a DC voltage. So the other side of the bridge rectifier is still going to be 120 volts, but it'll be DC. And I'm basically going to remove parts off of this board and build it onto my board bit by bit until I've copied the whole thing, because that's the American way, your favorite in-flight magazine. All right, I moved the bridge rectifier. We should see what it does. Well, we know what it does. We should test to see if it's doing what it's supposed to do. All right, we're gonna test this AC, 122 volts AC. So if we go to DC, we should see 120 volts DC at the other side of this bridge rectifier. Yep, 110 volts DC. So the first step is it takes the AC and turns it into DC. Now for the next step, we should turn that into a lower voltage. And that's what you use a transformer for. Transformers, more than meets the eye. Of course, we're also going to want to take this AC and put it into the triac. So we're going to have a triac heater control, and then we're also going to have the AC being turned into DC voltages for the electronic and motor portions. But for now, I'm going to unplug this so I don't get shocked. I think the way that I'm doing this is a stupid waste of time. Why don't I just take the existing package and cut it into this board? That would probably be a lot faster. So I'll just make a mark where this should go. And I'll kind of converge the boards into one. Yeah, I probably should have done that from the start. Wow, that was a lot simpler to make. So I've got the power supply here, the triac, and the optocoupler. I'm just gonna plug in this light to simulate our AC load. Got a battery pack here to activate the optocoupler. Plug in some power, optocoupler on, heating element on. Cool. All right, now that the power supply is done, I'm going to start building in the microcontroller circuitry up here. I wired in the AT Tiny 20, and I also have an 8-pin port here. I made a custom pin out for it for programming TPI interface. Then I made an adapter to go from the AVR Mark II to our glue gun, like that. So that'll work out pretty well. So we can program this with it powered off AC. So Felix is finishing up his H-bridge to drive the motor. In the meantime, I'll add a few more things to the AT Tiny, such as sensors and outputs. Okay, I scanned this with the flatbed scanner, which should bring it in at actual size. I actually scanned the back of it, but then I took a photo of the front and flipped it to make it fit. So I'm going to find out what these angles are, because remember, this is still based off of the foam version that we did. Actually, I should be able to just draw a line and get the angle from the line. 289 degrees. Oh, I see. Okay, so that's probably 19 degrees then, because it would be from 270 as a base. All right, my plan here is to draw a vector version of this circuit board, and then I can take that into Fusion 360 as a DXF, as a vector DXF. I can take that into Fusion 360 and then create a structure around it. Here's what I've 3D printed so far. It's the bottom half of our glue gun handle, and it's very gun-like. Turns out that fits your hand well. I think I'm gonna move the Hall effect sensor, because if you think about it, when you're pulling the trigger this way, if there's a magnet inside the trigger, it's gonna be a while before it gets, close enough to influence that Hall effect sensor. I did position the trigger in such a way that it actually goes over the Hall effect sensor, so we could actually put it anywhere in here. So if this is the default position, what I'll probably do is have the magnet like right about here where my finger is, and the Hall effect sensor will be here. And then the goal is when the trigger is fully pressed, the magnet should be centered over the Hall effect sensor. So yeah, I have to find out the right place so where it has influence in the full range, but doesn't go past it, because if you pulled it past it, you'd start to get a reading in another direction, although we could probably compensate for that in code. The rest of it feels pretty good. I'm printing the other half of this now, so we make sure everything is enclosed correctly. And while I do that, I'm gonna think about where to move the Hall effect sensor and also continue setting up my code. Okay, while that handle is printing, I'm gonna work on my code a little bit. So I created a function here, check button, so I can read buttons. So the first two inputs, PB0 and PB1, are also used for programming. So I've noticed, depending on what you attach to them, you might not be able to program while the system is together. So I'm just gonna use those two as buttons and use the internal pull-ups so it won't affect the programmer when you hook it up. Because if I were to attach like a LED and a resistor to it, that would actually prevent the system from entering programming mode. So I'm just going through and I'm just setting everything up. So we have our direction of the inputs, enabling the pull-up resistors on them, setting the output of the compared timer. I don't think I'm going to use the PWM for reverse. The reverse, I'll probably just hit it full speed for like a quarter of a second or something. That way I only need one PWM timer. I might be able to do two on this system, but I actually want to save that because I need it for like a servo or something. Yeah, so this is a quick test. We're going to see if the motor speed is running. And then we have this light that lights up. And then we have our check button 0, which lights up something. And then we'll also have check button 1. So yeah, I'm just creating some small, simple functions. And you've probably seen in Arduino where you use digital write or digital read. So what we're doing here is we're doing everything at low-level port access. So DDRB is the direction of port B, input output. PUEB, that's the pull-up resistor. So, if you have a button, you need to pull up or pull down resistor. So we set that internally. So we're just setting the input and output. So like here, if we want to set it, we do port port A, and then we do some binary shifting here to put the bit in the right position. So doing it this way is a lot faster than calling a digital write function, because you don't have to sit there and map out a pin number to a port. You just directly affect the port. Well, I'm just going to build up the code and write up my list of everything that we need. So far I have button 0, button 1, reset, motor PWM, motor reverse, trigger ADC, temperature ADC, and there'll probably be a few other things as well. So I'm just going to map those all to pins, and then I can solder more connections to my test board and get it as close as possible. So we could actually use the base that we're 3D printing, and we can build up from that to create our next prototype. Okay, I changed the position of the sensor and the magnet again. Now I have it that the magnet starts above the Hall effect sensor, and then as you pull the trigger 30 degrees, like that, it moves away. Now it certainly works, although the range is still kind of limited. So like if this is the start here, it takes a while before it even starts to move. Look at that, see? And then once it does start to move, it's very quick. I mean, pretty much the whole thing occurs in like 2 or 3 degrees. So that's not really optimal. I do want to keep the Hall effect sensor surface mount though. Well, I think part of the problem is just the magnetic field is not necessarily, well, it's not linear. It's more like a kind of a mushroom coming out the top and the bottom of a magnet. So I think that's why we're seeing like a really fast fall off. Also, like we kind of need to mount the magnet as it is shown here, because if you mounted it 90 degrees rotated, it would not fit within the trigger, and the trigger can't be too thick, else it will collide with the circuit board. Well, I'll have to keep experimenting, but once I have it figured out and get all the measurements in place, then it's a win.
Well, I realized why I wasn't getting the inverse of voltage at the terminals when I sent a 1 to either of the inputs, is because I forgot to connect the drains of the MOSFETs. I did that, and then I added some diodes, and now it seems to be working. So I'm going to do a test on camera. Hopefully nothing blows up. It was working great just a moment ago, so hopefully that continues.
Oh no! Magic smoke!
That smells good. That's some setup and payoff right there. Well, rather than just replacing this part that immediately exploded, I'm going to figure out why it exploded. I think I might have shorted something out somewhere.
So as you may know, we've been working on 3 long-term projects this year: Super Glue Gun, Logic Gate board game, and Mini Pinball Kit. Now the idea is to take those into proper prototype form and then hopefully kickstart them so they can turn into real products. So to help us with that, we have a special guest from the Element 14 team. Could you introduce yourself?
Thanks, Ben. My name is Hari Kalyanaraman, and I run our startup and maker programs in helping makers to market. And I would love to see the progress you guys have made on the 3 prototypes, and discuss how we can help you go to market.
So we talk about the Element 14 community quite a bit, but it sounds like Element 14 can help people realize their dreams from inception to production.
That's right, Ben. Element 14 is a one-stop shop to support every stage of product development, from concept to commercialization.
Tell us how this works.
Sure. So, you take a look at a typical product development cycle. You have your initial concept or idea, and then you refine that a little bit and try to define your products and what your requirements are.
Like we're doing right now.
That's exactly right. And then once you have an understanding of what the product requirements are, then you try to design the product, which is what you guys did right here.
But in our case, we can see some roadblocks coming, like where does a motor come from? Where does a hot end come from? How do we make our PCBs?
We can do it all. So Element 14 traditionally has been a distributor. So for the components, you got that part down. We are, we can help you source components and help optimize BOM. But we can also help procure PCBs, do the PCB assembly for you, any functional testing that needs to be done, and ultimately follow that through to production.
That sounds really cool. And even if a part isn't necessarily available easily in America, it doesn't really matter if the thing's being produced in China. You can figure out that supply chain as well.
Absolutely. So in fact, today we are the manufacturing partner for the Raspberry Pi, for the BeagleBone Black, for the BBC Microbit, and many other maker platforms.
Oh, I saw the BBC Microbit at Maker Faire.
That's right. And so we can do it all, and we are able to leverage our sourcing and production capabilities overseas in Shenzhen, China.
So do you think we're on the right track, though, with basically how we're building this up?
Yeah, I do. And I like the way you've stepped through this. You've demonstrated your proof of concept here, gone through a few iterations of prototypes, want to make sure you have everything exactly the way you need in terms of functionality and
Right.
performance, and then at which point we can help translate that into an integrated design on a
Right.
PCB.
Do you think there's a certain point where we should try to bring element 14 into the conversation with people such as you? Like maybe we shouldn't get too far in the design before consulting someone?
Absolutely. So our team of FAEs and design engineers are available, to consult, and even as you make like decisions about components and technologies and technologies and our experts can help you as you travel that path.
Do you see any major red flags with what we're doing so far with the glue gun?
Not that I can think of. I mean, you did mention you had some difficulty sourcing the motors, so that's something that we can look into.
I basically had to go online, to random sources like eBay, buy a bunch of motors that looked right, and then thankfully one worked. But yeah, if we could source that one that fits a head. So yeah, we would need to source the motor and source the 3D printed gear head. I even bought like 6 or 7 different types of 3D printer extruder gears, and we did tests with every one. Like we tested the current draw, the rotation speed, the glue grip, and it seemed like they were all within spec. This one I think was slightly better.
The other thing to keep in mind, to your point, I mean, you've done a great job like assembling this using parts that you could find.
Right.
The other thing that our team could do is look at these components for obsolescence and make sure that any component that's closer to like end of life
Right.
is caught on early in the development cycle, and we provide some alternates that can help you prolong this.
Here's a question, like should we, when we're designing this and sourcing components, should we basically target what our BOM needs to be in order to sell it for $100?
I would say so, and that's
Right.
why I asked like how far you are along in the
Right.
prototyping phase. Because if you're somewhat close, or if you're happy at least like functionally,
Right.
the quickest thing would be to evaluate the BOM along 2 lines. One is the cost, obviously, and then the second is just look at parts and obsolescence and make sure you capture any of those parts
Right.
ahead of time.
Well, thanks for coming to visit us, Mr. Hari. We really appreciate everything that you've shared with us. And we'll get back in touch with you a few months from now when we hopefully have a bomb and another prototype to share with you.
Absolutely. Thanks for having me both.
Ben, are you pleased with the progress we've made on the glue gun?
Yeah, so far everything seems to be working pretty well. Well, that's all the time we have for today.
If you have any comments or questions about our super glue gun build, remember to post those to the super glue gun subspace on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time.
We're getting back to our super glue gun build.
Previously, we selected all the components and made a test PCB. In today's episode, we're going to wire that up, attach the motor, trigger, and hot end.
I didn't solder it quite right and something exploded. It was spectacular.
It's about time we get something that looks good.